So the chain rule is a rule we need to use when we run into these functions where we can't put them into some product category or some quotient, or in this case we cannot isolate the power, so we can't apply the power rule here. So this is in fact an embedded function. So we have this green function embedded inside the square root function, and basically we have to work out the green function to generate an input for the red function. Okay, so we go from inside to outside. So when we do this, we have to kind of think of how does this inside function affect the change of the outside function. Okay, this is kind of very complicated and difficult to kind of think through, but we can kind of look at some models of this a little bit later. So right now we're just going to look at how do we actually do this? How do we do derivatives or rates of change for these embedded functions? And we need something called the chain rule. So the chain rule looks like this. And basically, to apply the chain rule, we'll differentiate from outside to inside. So if we want to take the derivative of this embedded function, outside function f, inside function g, first we differentiate the outside function, or we find the rate of change of the outside function, and we multiply it by the rate of change of the inside function. Or in other words, it looks like this. We have the derivative of f with respect to u, and then we have the derivative of u with respect to x. Okay, so we multiply these rates together. So this is how the chain rule works. So it's basically we're applying a chain. So I'm going to show you how these pieces work, but as we get better at it, we're going to start not using this notation of u. We're just going to try to differentiate from outside to inside without using all this notation. But for now, we're just going to use the notation just so that we get used to recognizing which pieces are which. So here I have to identify my inside function. My inside function is this x squared plus 2. The outside function is a square root. So if we describe this outside function, it's square root function, and the inside function is our quadratic function. So it looks like that. So if I want to differentiate this, essentially I want to find the derivative of f, or f prime of x, okay, and that's equal to the derivative of the outside function, okay, so we'll call that f prime, and with respect to the inside function, so g of x, we just leave that undifferentiated inside, and then we have to apply the chain, okay, we have to apply the chain of g prime of x. So there's what it looks like. So the u is my g function. Okay, so then as I do this, it's going to look like this. So I'm going to differentiate the outside. The outside is square root, so it's going to be 1 over 2 square root. That is the derivative of the outside function. Okay, regardless of whatever's on the inside, that is the derivative of the outside. So I'm just going to put my u in here as my variable. So then I need to differentiate the inside function up. Differentiate the outside square root. Now I focus on the derivative of the inside, which is 2x. Okay, so that's it. I've differentiated from outside to inside. If I want to see all the pieces in here, and again, eventually we're going to do this without the u, but for now we're just going to use the u just so that we can see what's going on. My u function is x squared plus 2 and then times 2x. So again, I've differentiated this is what the formula looks like. I differentiate outside, so I differentiate the square root, leaving the inside untouched, just like here. And then I add on a chain the derivative of the inside function. And then from there, I can just simplify this, and I end up with the 2's canceling out, so I end up with x over square root x squared plus 2, and that represents the change in the outside function with respect to the change in x.